Hello friends, in the previous class we discussed about how to draw a velocity diagram for a slider mechanism. Now we have to discuss how to solve the problems on a slider mechanism to find out the velocity of the different links. So for that, first take a problem on this. So an IC engine mechanism as shown in figure, in which crank AB rotates at a 600 rpm. The length of crank AB is 0.5 meter and connecting rod is 2 meter long. When the crank is turned at 45 degree from the inner dead center, find first bit velocity of piston P, second bit angular velocity of connecting rod BP, and third bit velocity of point D on the connecting rod, which is at a distance of 0.5 meter from B. So now we have to note down the given data. So in this, the length of the crank AB is equal to 0.5 meter and length of the connecting rod BP is equal to 2 meter long, and the crank makes an angle of 45 degree with the inner dead center, and crank rotates at a 600 rpm in a clockwise direction. So these are the given data. First you have to note down these data and we have to draw the configuration diagram. So for a configuration diagram, you have to select a scale. So here 1 centimeter is equal to 0.25 meter is taken because crank length is equal to 0.5 meter, then we can take a 2 centimeter long, and BP is 2 meter long, then for 2 meter long means 0.25 8 centimeter we can draw this. That's why I selected 1 centimeter equal to 0.25 meter scale. Now first of all mark a point A and draw a horizontal line. This is a line of stroke with a long and short dash. After this, measure the angle 45 degree and draw a line AB equal to 0.5 meter, that means 2 centimeter long. We get a point B. After this, take this B as a center and equal to the radius 8 centimeter. Cut this line of stroke, then we get a point P. Join this P to P. So this is called as a configuration diagram. According to the given data, first you have to with help of that data you have to draw the configuration diagram. Now when this crank AB is rotating in a clockwise direction and that is moving in a clockwise direction, so the velocity of the point B with respect to A is moving perpendicular to the line joining of AB. Perpendicular to the line joining of AB. So AB is here. So when this is moving in a clockwise direction, so perpendicular to AB is this one. Which one? This is. So this is the velocity of point B that is moving perpendicular to AB. Note down this first. So this is the velocity of point B. Now second one is velocity of B with respect to P. Velocity of B with respect to P, that is moving perpendicular to the line joining of BP. So perpendicular to this, draw a line. So this is velocity of BP. Velocity of BP. So velocity of BP is known and velocity of B with respect to fixed point A is known. Now we have to draw the velocity diagram. Before that, velocity of BA, velocity of B with respect to A is velocity of BA. So that will be equal to VB because the fixed point is the absolute velocity, that's why VB, that will be equal to VB. So this VB equal to omega AB into AB because phi equal to omega into R. The relation between the linear velocity and the angular velocity, phi equal to omega into R. So according to that, VB is velocity of B with respect to fixed point A, that is Vb equal to omega AB into AB. So omega AB is calculated, that means omega equal to 2 pi n divided by 60. N is given, that is 600 rpm. So 600, 2 pi into 600 divided by 60, that is equal to 62.5 into radius AB equal to 0.5 meter. You have to note on this. So that will be equal to 31.415 meter per second. 31.415 meter per second, that is velocity of B with respect to the fixed point A. So the magnitude and directions, both of these velocities are known. The magnitude is equal to 31.415 meter per second and direction is shown in the figure, that is like this. Now when the magnitude and direction of velocity B is known and the velocity of B with respect to P is only known in the direction, the magnitude is unknown. Yes. So before that, first we have to start the velocity diagram, draw the velocity diagram. So let us mark the fixed point. Fixed point is a here. So I will take this A on a paper. Now the velocity of B with respect to fixed point is in this direction. So parallel to this line, equal to the magnitude 31.415, draw a line. So we'll get a point B. Yes. So once this velocity of B is known in magnitude and direction, after that velocity of B with respect to fixed point is perpendicular to this BP. This is also known. So parallel to this line, draw a line from this point. But the magnitude is unknown here, only the direction is known. So just draw and leave it. Next one is velocity of P with respect to fixed point. Velocity of P with respect to fixed point B is moving along this line. So velocity of P with respect to fixed point A is a horizontal line. That's why I have to draw a horizontal line from this point A that will be intersect at this point at a point P. So this is called as a velocity diagram. This is a velocity diagram. So first of all, we have to draw a parallel to this VP, draw a line from the point A equal to the magnitude 31.415. Take any suitable scale. Next, velocity of B with respect to P is parallel to this line, draw a line, but we don't know the magnitude, leave it. Next, velocity of P with respect to fixed point is parallel to this line. So from the point A parallel to this line, draw this. So we'll get a point P. So the velocity diagram is completed. So from this velocity diagram, we can find out the velocity, the first bit, velocity of piston P. Velocity of piston P with respect to what? Fixed point. So measure this distance and convert it to scale. So that will be the velocity of piston. So velocity of piston is calculated here. Vp, that will be velocity of P is equal to OP into scale. Velocity of P, OP into scale. So OP length is 5.5. So scale is 5 meter per second. So Vp 27.5 meter per second is velocity of piston. So second bit, angular velocity of connecting rod BP. So afterwards we'll discuss about that. Third bit is velocity of point D on the connecting rod. Velocity of point D on the connecting rod, which is at a distance of 0.5 meter from B. So the point D is given here, that the point D is 0.5 meter from this point B. Now similarly, you have to mark the point D on the velocity diagram. The point D is in between the point B and P. So here D is here and this is a point P. So in between this PP, the point D will be there. So at what distance that is, we we have to find out the distance of BD. So for that, take this relation. Velocity of point D, first you have to mark this, BP divided by BD will be equal to PB or BP divided by BD. So from this equation, BD will be equal to this one. So put the values of BD, 0.5 divided by 2 into 4.4, then we'll get 1.1. So mark this 1.1 centimeter from the point B. So the point D will be obtained. So after getting this point D, velocity of point D, that will be velocity of point D is equal to AD. Velocity of point D is what? Velocity of D with respect to fixed point A. So that will be equal to AD into scale. AD into scale. So 5.6 into 5. So that is 28 meter per second is velocity of point D with respect to the point A. So the answer for the third question is completed. Now come to the second question, the angular velocity of connecting rod BP. So angular velocity of connecting rod BP is shown here. So angular velocity of connecting rod BP is equal to omega BP. So we know the relation phi equal to omega into r. So phi BP will be equal to PB into omega BP. So omega BP will be equal to phi BP divided by PB. So put the values of phi BP, and so that is 11 radians per second is the answer. So like this you have to draw the velocity diagram.